Okay, back again. So we have a second substrate talk, which is good. It's always like to see these things grouped together. So we've got Kyle Friedman, who's from the Jiffy Group, and he's going to talk about what makes an effective substrate for the future of controlled environment ag. And as I said in the last talk, something pinged up on me saying the cocoa substrate market's going nuts at the moment and the demand is huge. So these talks are very timely. Kyle, it's all yours.
Awesome. Thank you so much. Good morning, good afternoon, good evening, wherever you may be. As was mentioned, my name is Kyle Friedman. I'm the Global Market Segment Manager for Controlled Environment Ag for Jiffy. Really excited to be here and part of this conference. I think, as many of us know, the past 10 to 15 years within the controlled environment ag industry, we've seen such technological change and advancement when it comes to lighting, when it comes to automation, when it comes to systems, sensors, all of these different components. And I think substrate and growing media has been a little bit slower to change and sort of get on board with changes that the market and growers are demanding. And I think we're starting to see sort of that uptick of those changes. And so I'm really going to highlight what makes an effective substrate for the future of CEA and some of the key elements that the market is driving advancement in substrate that I think we're going to start to see. So a little bit about Jiffy, if you're not familiar with us. We are a growing media provider that is a global company, and we really define ourselves as having control over raw material resources such as peat, such as coconut coir, such as wood fiber. But I really like to think of us as taking these raw materials and really creating a suite of value-added products that are really geared and intended for supporting increases in efficiency and productivity and new systems that really show the advancements within CEA. We like to say at Jiffy that we're everywhere for everybody. So as I mentioned, we are a global company. We're located in over 9 countries, which really helps us give better access to our growers regardless of location. That really can help with cost effectiveness and just better technical support. I am located in the United States, so the green segment that's highlighted there, even though my role is global. And I've connected with many of you before and look forward to continuing to make more connections. So jumping into kind of an overview of this presentation and some of the elements that I'm going to cover, I like to think of summary of this presentation as going from dirt to design. And obviously, if you speak to a soil scientist and you say the word dirt when you're referring to soil as substrates, they might yell at you. But I like to use that term because of the way the substrate industry has moved. It's been a little slow to change. And when we've talked about substrate and growing media, we kind of have one image in our mind, right? But what we're really seeing is we're moving from that more primitive stage to an era of design, an era of engineering, and really fine-tuning what substrate products can be for the CEA market. And so there are 3 essential components that I see driving changes in growing media and substrate, and those are automation, food safe products, and sustainable. And these aren't necessarily new topics for some of us, but there are elements of each of these that I find to be critical, that we have products on the market that meet, and then lots of opportunity and room for growth within these 3 different elements. So starting out, automation is such a critical component of CEA. We all know that with changes in lighting, sensor technology, production systems, we're really having to rapidly keep pace with these changes. And substrate is a critical element of that. And there are some specific components and features of substrate that can really lend themselves well to be used in automated systems. And so one of those is really being able to customize your substrate product. And that really starts with raw materials. There are so many different materials on the market that can be used for substrate. Again, I had mentioned peat, coconut coir, wood fiber, whether it's inert material, etc. Having the ability to be a grower and pick and choose the different materials based on your objectives and fit those into a product that can be used for automation is critical. And so I think we're going to see in the future a lot more ability of growers to make those changes and really have a plethora of options available to customize those products. Physical and chemical properties are essential within growing media. That really hasn't changed for a long time. And that really boils down to looking at porosity, water holding capacity, things like pH, EC, nutrient content, not just getting a substrate anymore and being able to drive those components based on your production goals, but really being able to fine tune and select what you want in a growing media product from the get-go before it actually comes to you in your production site, and being able to make those tweaks. So physical and chemical properties are essential. I'm not going to go into too much detail on this, but just to know that customization within these areas and being able to sort of engineer and design those elements is going to be more and more critical. So further in customization, that's essential for automation. So shape and size is probably one of the biggest, and this comes down to whether it's young plant propagation at the seed stage or clonal propagation, all the way up to finished production. Understanding options available to you for shape and size are critical for a variety of different elements. So crop specificity is a big one. Certain crops like different size plugs or different shapes, and you can make that selection based on the crops that you're growing. And many of our CEA producers are now increasing the diversity of options that they offer and products that they're growing. And so being able to switch between growing media sizes based on your crop is really important. Final cavity space. So I like the saying of begin with the end in mind. I think that's really critical with really any component of CEA in terms of establishing your facility, your production system. And it's important for substrate as well. Being able to just build your system and buy a substrate off the market doesn't always work. And so we have a lot of growers who, even before their facility has been built, that they're starting to think about what substrate options they want to use, the shape and size of those plugs, those trays, things like that, so that it can really work efficiently in their system. Germination is another critical component. As I mentioned, not all crops germinate well in just any given cell size or any plug size, and so you really have to dial in what crop you're growing, what kind of germination is best suited for that crop, and then really be able to select size and shape based on that. Irrigation regime is another important component, depending on how you water, what your production system is, whether it's NFT or ebb and flow or deep water culture or something like that, that can impact water holding capacity and uptake of that substrate in those systems. Transplanters, so we're going to talk a little bit about this, and I know there's been some presentations from transplanting and other automation companies within this conference. That is a critical one for customizing growing media solutions for CEA, and so we'll go into that a little bit more. And then crop cycle, so being able to speed up your crop cycle could be is critical for productivity, for efficiency, for return, and being able to move through your production cycle faster based on shape and size of a solution that you can select for is really important. And especially within CEA systems, we're working with more plants in less space and higher density. So understanding how you can start with certain size growing media options and be able to scale is really important. So further in customization, dibbling is really important. When we talk about dibbling, we're actually talking about indentations that can be made in plugs. And that's really critical to know that as a grower, you have sort of a range of options for that. And part of that is because of seed size and shape. And this is really to improve germination and really get plant growth and development off on the right start. Whether using a pelleted seed or just a raw naked seed, having the right dibble matched to your seeder is really important to make sure that your production system goes smoothly. And so again, understanding that there's a wide range of customization that can happen. And I think we'll continue to see more of this as we move forward, as crops change, maybe as we see more clonal propagation happening in CA, specifically with food crops, that'll become important. And especially with cuttings, there's a wide range of size of type of plant that you're using, and making sure you have that right dibble can be essential for good growth. So moving on into automated systems that are important for transplantability. I think within growing media, this is one of the most important elements. And this is because as we see more automation within CEA, we can't just use any growing media product to move a crop from an early stage and get that transplanted into a final system and not have any issues throughout that process. And so when I talk about transplantability, I think one of the critical factors is really maintaining integrity of that substrate. And when I say maintain integrity of that substrate, there's a couple of areas that I'm thinking about. One is preventing plugs from falling apart. And again, if we think about loose fill mixes in a CEA system, which can work, if we have a couple day germination time and then we're moving to a nursery stage for a little bit more time and then trying to move that crop and that plug into a final location, you might not have full root development to really hold that growing media together. And I think a good image in your mind is kind of taking a more traditional plant out of a pot and seeing that good root development with plugs and propagation within CEA. We don't necessarily have that yet because our crop cycle is pretty quick. And so having a product that keeps that growing media together and can move a seedling at a very young stage without risk of those plugs and that growing media falling apart and contributing to losses is really critical. And I think that's going to be more and more important as we move through advances in CEA, more automation and making sure that's an element of a grower's production system. Preventing debris is also another important area, and I think we talk a lot about this given that there's more water recirculation systems happening within CEA. And so if you're using growing media solutions that are prone to crumble or break apart or are just not really held together nicely, then you're going to get more debris in your system, and that's going to cause issues for circulation and not be effective for production. And so with transplantability, that's an important element that that we focus on. And then minimizing production time. So I had mentioned just thinking about leafy greens within CEA, how quick that crop turn is, and moving from germination through production, you don't always have that good root development that I talked about. But if you don't have good root development and you can still move those seedlings and that crop through your system without worrying about whether that growing media is going to fall apart, then that's going to minimize your production time and you can get through more crop cycles faster. And ultimately, that's going to have an effect on a grower's bottom line. So in addition, transplantability within automation systems and growing media can be achieved by a couple different areas. So one is bound media. And when we talk about bound media within our industry, we're talking about physical characteristics of growing media, specifically plugs used for young plant propagation, that regardless of whether you have a seedling in there, regardless of whether you have good root development, that substrate is going to be held together. And that's not typically what happens with a lot of substrate. And so a transplanter focusing on automation can easily move that media product regardless of the development stage. And I think that's really critical and a benefit to growers looking to scale, to reduce labor and to increase automation. Encapsulation, this isn't a technical term necessarily within growing media, but it's a term I use for having a growing media product that is fully encased or enclosed by some substance or material. Again, similar to bound media, that growing media is being held together from top to bottom and is reducing any risk of media being shed within your system. And so plays really well with automation, with moving that crop and not having to worry about it falling apart or any debris. And then more traditional containerized systems that we all know of. Obviously, if your media is within a container, you can move that container and not have to worry about a risk of any media breaking apart or any issues with transplanting in other automated systems. So moving on from automation, food safety is a critical topic. There's probably a lot of sessions within this conference and other conferences that you've been to that are focusing on food safety specifically for food crops. And growing media is not removed from that discussion. And so this is a big trend and a big conversation that's happening now and will continue to be important as growing media solutions evolve and making sure that food safety is a critical component of that. And there's a couple different elements that I'll highlight, trends where we see some advancement in ability to minimize pathogen risks, but also just future opportunities for this that Jiffy's working on, and I'm sure others are working on to make sure we can provide growers with these solutions. So organic materials and microbial diversity and that connection. And we don't often think about that, but a lot of the materials that are on the market, such as peat, such as cocoa core, such as wood fiber, there is a range of microbial diversity based on these products, and not saying that one is necessarily better than the other. And I'll talk a little bit about sort of this topic of microbial diversity a little bit more. But when we look at products like peat that are harvested more at the ground level, they're going to have increased diversity because they're closer to the soil. Cocoa core being a waste product and a byproduct from harvesting coconuts for other food and different products and using that waste is going to be a little bit less, just given that it's not coming from the soil and is a waste product. And then wood fiber as well, we see a little bit less microbial diversity there. And again, there's good and bad elements to this diversity, which we'll touch on. And processes really impact the diversity between these three. And I'm just highlighting these three because they're the main material constituents of growing media that we often see. But there is a range of diversity that we find. And as more products come on the market and we have new materials available for growers to select within their blend or their mix or their products that they're using, I think we'll see products that have reduced pathogen risk, whether it's a natural material that might be harvested like peat, whether it's a byproduct from the cocoa industry or the wood fiber industry. We'll see, and we're seeing new products that are hitting the market that have attributes that lend themselves to reduce pathogen risk. And I think that's really important to think about within the CEA market. Another element is really more efficient and cost-effective methods to manage pathogens. And so there's a variety of ways that this is accomplished now and will continue to be accomplished. One of those is biocontrol. We see a lot of different products on the market that can add in some microbial component to growing media to prevent pathogen risk. I think there's still a lot we can learn about this to really figure out which microbes work best and how best to use those products. Sterilization is a topic that comes up a little bit, and we still don't know a lot about using those options and whether they might reduce integrity of growing media or how it impacts some of those characteristics. And so I think there's opportunity to look into that more for products that are available. Sensor technology, we see so much sensor technology, whether it's for managing water, for lighting, for other conditions. We don't really see a lot for monitoring pathogens and really monitoring microbial developments within substrates. So I think that's an interesting area that we might look to in the future. And then traceability we have, but just making sure as a grower you understand that products that you might find on the market should have traceability from harvest all the way till it gets to your facility. And within all of these, and especially like sensor technology, sterilization, there is a cost, and we still have to see what data is available for that. And then again, just with microbiome, ConserBio was talking about this. I think they're having a presentation at the same time. And so just understanding improving growing media microbiome, I think that is a really important topic. And we focus so much on microbiome diversity for human health as being a benefit. And I think we have to remember that plants coming from a natural environment also have a microbiome and diversity. And this is an important element because it can increase overall competition within growing media and prevent pathogen risk. And so there's interesting advancements going on there, and something that I think we'll see more. And then finally, within sustainability, we talk about sustainability all the time. And I think when we have those conversations, it's really important to say, well, what do we mean? Because there's a lot of elements of sustainability, and that can be reduced plastics, that can be reduced carbon footprint, that can be biodegradability or circular economy, just to name a few. And I'm just going to highlight a couple of different elements that I think are important and will be more important. Reduce plastic, so whether that's going plastic free for containers, whether it's post-consumer recycled materials, so taking existing plastic, recycling it back into containers, bags, or trays in the case of CEA and propagation. And then with reusability, we're seeing more and more injection molded trays used to meet some of those sustainability goals, and we'll continue to see more of that. And then finally, biodegradability. We talk a lot about biodegradability versus compostability within growing media, and I think it's important to define those and understand what we're talking about. And so with biodegradability, that's naturally broken down into its original elements with enough time. Plastic can be biodegradable in the sense that it can break down to its original plastic materials within the ground, and that's not a good thing, but that's still defined as biodegradability. Whereas compostability, we can be reducing components down to be a nutrient rich mix that can then feed back into nature or back into value added products. And so I think within growing media and CEA, I think we're looking to return these material components back to the soil without negative effects. And there will be a lot more advancement with value added products to meet some of those areas. So just kind of wrapping this all up, since we're about time and we want to get to some questions. The future CEA substrate solutions are really going to put all these elements together. So when we talk about automation, food safety, sustainability, right now, I think at times there can be a little bit of an imbalance because automation might take precedent, and we're trying to figure out what we want with food safety or sustainability. And the goal is really to bring all three of these elements together. And that's what we're going to see as we move forward with CEA advancements and evolution within growing media. So thank you again for the time. I know 20-minute presentations are pretty quick. Happy to take any questions. Please feel free to reach out and connect with me, and would love to talk more about some of these topics and products. So I will stop there.
Okay, thanks, Kyle. That was good. We've got a short amount of time for questions. So the interesting one is, what about how can increasing growing media microbiome help reduce pathogen risks, or actually, and the plant production as well?
Yeah, that's a great question. I think that's a topic that deserves a lot of attention now. Our friends at ConserBio, Paul, I think, is speaking about some elements of that right now. I think there's this kind of debate within our industry of, do we go with a sterile or inert product? Do we go with something that's organic? And what is the ultimate difference? And I think understanding the microbial diversity of growing media can really provide some benefits and positives, whether it's that element of competition, just like human health and microbial diversity, to reduce competition of pathogens from taking hold of larger populations and developing, or whether it's having a bump in yield and productivity that we've seen in some of the research. And so whether you're using an organic material, an inert material, whatever that may be, microbial diversity is an important element that there's a lot of interesting research going on now, and I think can be important going forward.
Okay, cool. In the interest of time, I'm afraid we can't have any more questions. There are a couple there, so you can go backstage and ask through the messaging facility, contact Kyle, because there were good questions about biogel substrates. water runoff, potentially guaranteeing sterile or pathogen-free substrates. So clearly ones that Kyle will have an interest in and he can answer. So thanks again, Kyle, and hopefully we'll see you soon.
Thanks, sounds good, and look forward to connecting and answering some of those questions.